So in this video, we are going to see standard type 4, which is otherwise called a separable equation. Separable equation means here we can able to separate the equations by xp, function of xp one side and function of y and q another side. For example, look into this problem. Q into p minus sine x is equal to cos y. So here we are having functions involving x, y, p and q. Okay. So all the four things we are having. So now we have to separate px one side and qy another side. So while separating that, we can write the given equation as p minus sine x is equal to cos y divided by q. So in this case, for separable equation, after separating xp one side and yq another side, we have to consider both equal to some arbitrary constant a. Okay, so here a is called as arbitrary constant. So now after assuming it to be a, equate it separately. So p minus sin x is equal to a. Similarly, another equation is cos y divided by q is equal to a. So while separating it, we can write p as a function of x and a. So we can have a plus, taking sin x to right side, it becomes plus sin x. So we can have p is equal to a plus sin x, which is a function of x and a alone. Similarly, here we have to take q as a function of a and y. So here by cross multiplying this q and a, we can have q is equal to cos y divided by a. Now we are having q as a function of y and the arbitrary function a. Now again we have to remember about this equation. Dz is equal to p dx plus q dy. So p dx plus q dy means here p can be substituted as a plus sine x into dx plus q is cos y divided by a into dy. So this is the reason why we are separating px one side and qy another side. So this p will give you function of x alone. Again q will give you function of y alone along with the given arbitrary constant. Now integrating this, we have z is equal to, this becomes ax plus, here integration of sin x is minus cos x plus 1 by a into integration of cos y is plus sin y plus arbitrary constant c. Okay, so now this is the complete integral where we are having two arbitrary constants a and c. So that we can write the complete integral as z is equal to ax minus cos x plus sin y divided by a plus c. This is the complete integral. Now as usual, singular integral, while differentiating partially with respect to c, we get an observed result, so there is no singular integral. And then general integral is, as usual, we have to fix c is equal to f of a by usual technique, differentiating with respect to a and eliminating a, we obtained the general integral. So we can move on to one more question, that is py minus x square q square is equal to x square y. So again if we see here, we are having p, q, x and y, which we can able to separate px one side and qy another side. So while doing like that, here we can write the given equation as py is equal to x square y, and we can take this x square q square to right side as plus x square q square. Now we can write here by taking x square as a common term, so which gives you y plus q square into py. Okay, so that here we want p and x one side. So take this x square to left side. Again here take this left to left side, this y variable to the right side as y plus q square divided by y. Now if we see this given equation has been separated by having p and x one side, q and y another side. So now this can be taken as some arbitrary constant a. Now equating it separately, p by x square can be equated to a. In a similar way, y plus q square divided by y can be considered as a. So that here p is equal to a into x square, and then here we have to get q. So q means actually here we cross multiply, we'll be having a into y. So this q square can be written as ay minus y, or otherwise a minus 1 into y. So now again we have to remember the equation, and moreover q square is this, but we want only q. So taking square root on both the sides, we have q is equal to root of a minus 1 into y. So now we have to remember about the equation dz is equal to p dx plus q dy. So dz is equal to p is nothing but ax square. So we can write ax square dx plus q is nothing but root of a minus 1 into root y into dy. Now on integration, this gives you z equal to a x cube by 3 plus root of a minus 1 is constant. Again root y means y power 1 by 2. On integration, this becomes y power 3 by 2 divided by 3 by 2 plus c. Okay, so here we can write this is equal to, or otherwise we can write take LCM on both the sides. 3 we are having, so that we can cross multiply that. So 3z is equal to ax cube plus root of a minus 1 into 2 times. This 2 will go to the numerator. So 2 into y power 3 by 2 plus again 3 into c is another constant. Let it be c dash. So now this is the complete integral. Next is singular integral. By differentiating with respect to c, we get an absurd result. So there exists no singular integral. And general integral, we obtained it by putting c is equal to f of a and differentiating with respect to a and eliminating a, we obtained the general integral.